You are at a forest junction with no sign you recognize. Your phone has no service. One trunk is thick with moss, and an old survival rule comes back to you: moss grows on the north side of trees. Should you use it to choose a direction? No. Not as a navigation decision. The useful lesson is not that nature gives no clues. It is that a clue is not the same thing as a bearing. Moss can tell you a great deal about moisture, shade, bark, and the tiny climate around a tree. But if being wrong would send you farther from a trail, road, campsite, or rescue route, the moss is not reliable enough to vote by itself. In this field guide, we will test the myth, explain why it sometimes appears to work, and replace it with a repeatable rule you can actually carry into the woods. Start with the mistake. The phrase, "moss grows on the north side," compresses a local tendency into a universal law. In parts of the northern hemisphere, a north-facing surface may receive less direct sun. It may stay cooler and damp longer. Those conditions can favor moss. That is the grain of truth that keeps the rule alive. But a forest is not a clean compass rose. A trunk may be shaded from the south by another tree. A slope may hold cold air and moisture on one side. Prevailing rain may wet one face. Bark texture, drainage, canopy gaps, nearby rock, streams, fog, wind, and tree species all change the microclimate. In a wet forest, moss may wrap around the whole trunk. In a dry forest, there may be almost none. On a leaning tree, the wetter surface may be determined more by runoff than direction. So here is a safe field test. Do this only in a familiar area, on a marked trail, in daylight, with a real compass. It is an observation exercise, not permission to navigate off trail. First, stand away from metal objects, phones, trekking poles, vehicles, and anything else that could disturb a magnetic compass. Let the needle settle. Identify north. Second, look at one mossy trunk. Before checking every side, predict which face has the greatest moss cover. Compare it with the compass. Record the result mentally or in a notebook. Third, repeat the observation on at least 10 trees or rocks spread across the same small area. Do not select only the examples that fit the same. Include trunks in deep shade, near openings, on slopes, and beside wetter ground. Fourth, change the question. Instead of asking, "Which way is north?" ask, "Which surface stays coolest or dampest here?" Look up. Is another tree blocking sunlight? Is the ground lower on one side? Does water run down the bark? Is dense canopy creating shade that has nothing to do with north? Most people find that the first tree can look convincing. The larger sample becomes messy. Some moss faces roughly north. Some faces east or west. Some surrounds the trunk. The test exposes the problem. A navigation tool must work when you need it, not merely produce a memorable example when conditions happen to agree. Now compare that with a baseplate compass. A compass does not know where your trail is, but it gives a repeatable magnetic direction. A map adds terrain, roads, drainages, boundaries, and landmarks. Together, map and compass let you form and test a route hypothesis. REI's navigation guidance teaches orienting a map, setting declination, taking bearings, and using features on the ground. The National Park Service similarly treats compass skill as a practical way to establish direction. Leave no trace includes navigation tools among the essentials because planning prevents wrong turns, shortcuts, and avoidable impacts. This does not mean electronics are useless. An offline map on a charged phone or dedicated GPS can be excellent. A satellite communicator can help summon assistance when appropriate. But batteries fail, screens break, downloaded coverage can be incomplete, and a location dot still does not make a dangerous route safe. The stronger system has layers: trip plan, paper map, compass, offline map, known landmarks, and the judgment to stop before uncertainty multiplies. Natural clues still belong in that system, but as supporting evidence. The sun's general arc, slope aspect, prevailing weather, a mapped ridgeline, the sound of a road, or the direction of a known drainage can help confirm a position. Each clue has assumptions. Clouds hide the sun. Water does not always lead to people, and following a drainage can lead into cliffs, waterfalls, brush, private land, or flood terrain. Sounds bend in valleys. One clue may be wrong. Several independent clues that agree with a map and compass are more useful. Here is the field reasoning that matters. Separate orientation from route choice. Orientation asks, which direction am I facing, and approximately where am I? Route choice asks, what movement is safe, legal, and likely to improve the situation. Even a perfect north arrow cannot answer the second question by itself. North might point away from the trail. A straight line might cross a river, cliff, avalanche slope, dense brush, or closed land. That is why the safest response to uncertainty is often to stop, not to improvise a natural compass. Recall your last confirmed location. Compare the terrain around you with the map. Check time, weather, daylight, injuries, and the ability of your group. If you cannot confidently identify a short, safe retrace, wandering to test a guess usually makes search and rescue harder. The U.S. Forest Service advises lost visitors not to walk aimlessly, to try to become oriented, and to use reliable navigation tools. Depending on the situation and local guidance, staying in a safe, visible place and signaling may be better than moving. Movement can still be necessary to escape an immediate hazard, reach a clearly known nearby location, or follow a rescue plan. But that decision should rest on more than moss. There is also a leave-no-trace reason to avoid guess-driven travel. Wrong turns create shortcuts, trampled vegetation, damaged biological soil crust, and unnecessary disturbance. Good navigation is not only survival equipment. It is a way to keep your impact on durable routes and surfaces. Before the next trip, build the skill under low stakes. Learn how your compass behaves. Set the correct declination for your area. Practice orienting a paper map at a local park. Mark the trailhead, major junctions, water crossings, and obvious handrails such as roads or ridges. Download maps before leaving coverage. Tell someone your route and return time. Carry a headlamp, weather protection, water, food, and a way to signal. Then run the moss test for fun. Observe whether moss in that particular place favors shade, moisture, rough bark, or a direction. You will learn more about the forest by dropping the slogan than by trying to prove it. The conservative safety caveat is simple: no video can evaluate your exact terrain, weather, health, local regulations, or rescue resources. A compass requires training and local magnetic declination. Do not leave a known route, enter hazardous terrain, or delay an emergency call just to perform a field test. Follow current land manager guidance. If there is immediate danger, act to get out of that danger. If you are genuinely lost, use the appropriate emergency and rescue procedures for the area. So, can moss point north? Sometimes it may lean that way. That is not the same as knowing north, and knowing north is not the same as knowing the safe route. Use this repeatable field rule: natural signs can confirm, they do not command. Navigate with a map, compass, and multiple independent checks. If those checks do not agree, stop the movement before the error grows. Moss is a habitat clue. Your route deserves evidence.